Okay, this under this condition, when A beta is very much large, this 1 plus A beta will become A beta. So A and A will get cancelled, where AF will become approximately equal to 1 by beta. Okay, so where beta is called as a feedback ratio. So here the gain depends on the operating potential and the characteristics of transistor. Here the gain depends only on beta. Beta is going to be the feedback factor. It does not depend on the transistor parameter capital A. Capital A is the gain of your transistor. So gain completely depends only on the feedback network. So if the feedback network contains only stable passive elements, then the gain of the amplifier with feedback is also stable. Main thing when you compare positive and negative feedback, positive feedback, the amplifier is unstable because the gain is infinity, but here the gain is reduced, so it makes your amplifier very much highly stable. And also one more thing, the gain of the amplifier with feedback AF, it is approximately 1 by beta. Beta is going to be the external circuit what you are going to connect for as the feedback network. So the AF does not depend on any of the transistor parameters, so it is independent on of the transistor characteristics or the operating quiescent point of your transistor. The stabilization of the DC operating point of the transistor is accomplished by the use of negative feedback. One important thing, we said positive feedback is highly unstable, but negative feedback adds stability to your amplifier. It will fix the Q point exactly in the middle. So it will ensure that the amplifier is going to be highly stable. So the operating point is kept constant even in the case of change in temperature or change in HFE or beta or change in VBE of the transistor. So we have seen the very first unit about the stability, right? So stability is altered when the temperature is going to vary. The temperature is going to vary. Three parameters in your transistor is going to change. One is collector current IC, another one is beta or the current gain of your transistor, and third one is VBE. So if these three are going to change, the operating point is going to change and the transistor is not going to work properly, right? So by using a negative feedback, all these problems relating to biasing will be completely ignored because the feedback will take care of the biasing. The feedback will always ensure that the Q point is exactly in the middle of your DC load line. Okay, so that is a very, very important property of negative feedback. So negative feedback is used to improve the performance of electronic amplifier. So it will negative positive feedback. What all drawbacks you had? The positive feedback is unstable. Negative feedback is more stable. In positive feedback, the bandwidth is very poor, but in negative feedback, the bandwidth is very high. In positive feedback, the noise and distortion are very high, but here the noise and distortion are very less. So the resistances can be modified as desired. So all the above advantages are very good and they are effectively seen in negative feedback, but it has only one drawback: the voltage gain is less. Because of negative feedback, the voltage gain is less. Applications which does not bother about voltage gain, they bother about only the noise, distortion, bandwidth, other properties. For that, negative feedback would be a very good choice. But if you are more focusing on gain, I want the amplifier to have a very high gain even if I apply feedback, then this negative feedback would not be an ideal solution for you, because when you use negative feedback, it is natural that the gain will be reduced. Only at the expense of reduction in gain, you are getting all the above benefits. Okay, only drawback of negative feedback is reduced voltage gain. Otherwise, all the points which are favorable to any amplifier is seen here as favorable for feedback amplifiers. Also, only one thing, the reduction in gain or reduced value of voltage gain is the only drawback which you see in negative feedback. So the block diagram of feedback amplifier consisting, we have already seen this block diagram. Now we are going to see the different types of sampling networks and mixing networks. Any doubt in the two types of feedback and the value of gain? Anybody is having doubts? I'm going to pause for a few seconds. Please ask your queries regarding the two types of feedback, positive and negative feedback, whatever you studied so far. Any queries or doubts you have regarding the types of feedback? Are things clear?